right, so I've been asked to do 2019 number 6. I'm going to do it. It's kind of a hard one, but we're going to do it anyway. It says f, g, and h are twice differentiable, and g of 2, h of 2 are both 4, and then the tangent line for both graphs are this is that tangent line. If you notice, they took the y minus 4 and they added the 4 over. Well, we want to find h prime at 2. So what that means is, since this same equation is the tangent line to both of those, that means that this is the slope of both of those. So since that is the slope of both of those, this answer is that slope of the tangent line, because the slope of the tangent line equals the derivative of the function at that point. And because the point right here is that 2, that's the same as these 2's for those. So that is 2/3 right from the tangent line. The next problem says we want to find the derivative. So we got to take this thing, and I'm going to use 3x cubed as the first term, and the hx as the second term, and do product rules. So h prime of x is going to equal the first, which is 3x cubed, times the derivative of the second, which is h prime of x, plus the second term, which is h of x, times the derivative of the first term, which would be 9x. And then I'm supposed to go and I'm supposed to find, and by the way, you get 1 point for doing that. And then you're going to go and you're going to plug in 2's for all the x's. So right here, I'm going to actually, the only two things I really got to change is I've got to find h prime of 2 and h of 2. Well, they gave me h of 2 is 4 here. And we just found here in this problem that h prime was 2/3, if you don't remember. So you really don't have to solve this. You just got to put those values in. If you want to solve it, you can. Let's see, 2 cubed is 8. 8 times 3 is 24. And h prime is 2/3. And then we got plus h of 2, which they gave us up there again is 4 times 9 times 2. And that right there is good enough for the answer. If you solve that, you would get 160 if you went ahead and solved that. Okay, problem number 3 to me is super hard, and I don't think there's going to be one like that on this year's test, but it could be. So it tells you the function of h satisfies this, except for x equals, or x cannot equal 2 will not work there. So what that is telling me, that little thing right there is telling me that 2 is going to get you 0 in the numerator. This value, when you do the limit, when you do the limit as x approaches 2, it's going to be 0. And when you do the limit of this down here, it would be 0 when you do them at the same time. So we're trying to find this. Now it says it can be evaluated by L'Hopital. So there's another reason we know that's going to be 0 over 0. And hopefully we know we can fix that. So we want to find the limit of this function as it approaches 2. So that limit right there by L'Hopital is also going to give us the derivative. So that thing right there is also going to equal the limit as x approaches 2. And L'Hopital says that you can do the derivative of the top part, which is 2x, and the derivative of the bottom part. Well, that derivative of the bottom part is going to be, the derivative of 1 is 0. Then I got to do chain rule, so I got to bring the 3 down first. So that's going to be 3. And then I'm going to have f of x to the second, and then times the derivative of f of x. So what that tells me is this is going to be 2 times 2 in the top. And on the bottom, I'm going to have -3 times f of 2 squared times f prime of 2. So I'm going to have to find f of 2 and f prime of 2. Well, that's going to be a little bit hard, but I think we can do it. So do you remember up here above, we said that that has to equal 0. So that can count. I can solve this then for f of 2 by taking 1 minus f of x equals 0. And that's actually going to be when I plug in the 2, if you don't recall. That means that is f of 2. So if you add f of 2 over, you get that f of 2 is going to equal 1. So that means I can stick a 1 in here for this thing right here. This value is a 1. And then I need to find f prime of 2, which is kind of hard. So because of this twice differentiable statement up here about f, g, and h being twice differentiable, that means that they are continuous. So you need to actually say that f is continuous. And I would say all of them. It'd probably be best to do it at the top. You should say are continuous. And you could also say, since it's twice differentiable, you should also say that f prime, g prime, and an h prime are also continuous, because twice differentiable means that their first derivatives are all continuous. And we're probably going to have to use that later. So now I want to find f prime of 2. Well, I know f prime of 2 exists because of what I just said there. This tells me that f prime of 2 exists because of them being continuous. I know f prime of 2 has to exist. So then I need to find f prime of 2. Well, again, what that tells me is, you remember we got this equation right here. And because they're all differentiable, the limit is also equal to this, the limit of these things. Remember, we're doing this limit. And we are supposed to know that the limit of this, because of this information right up here, the limit of this has to equal the point, because you're going from both right and left, and you got to get the same value. So we need to take this this equation right here and put it equal to 4. So when we do that, 2 times 2 is 4 in the numerator there, and then we got -3, and then 1 squared is still 1, and I got that times f prime of 2, and that equals 4. So I'm going to take the entire denominator, this entire thing right here, and I'm going to multiply it over to the other side. I'm actually, well, I tell you what, I'm just going to multiply the f prime over the f prime of 2. So I'm going to multiply this side by f prime of 2 and this side by f prime of 2 to get these to reduce, because I'm supposed to be finding f prime of 2. And then I'm going to divide this side by 4. And I'm going to divide this side by 4. So those two things reduce out, as well as these two things that reduced out. So that tells me that f prime of 2 is going to equal, let's see, that'd be -1/3, because I've everything in the numerator reduced out to 1. And then that -3 right there is all that's left in the bottom, and those reduced out. So f prime of 2 is -1/3. So that was a pretty difficult problem. And again, I don't think there's going to be one quite that hard. Okay. And by the way, just so we make sure we know, this limit is 4 because of what it says up here. Remember, when you approach a value from the left and a value from the right, they have to come together at the same point, and it's telling you that value is 4 right there, because h of 2 is 4. Remember, the 3 steps for something being continuous is h of 2 has to exist, and the limit from the left and the right have to equal that. That's why that's still, this answer right here has to be 4 for that part. Okay, so pretty difficult problem. I don't know if that'll be seen this year. And then this part B is extremely difficult too. Now this is kind of tricky because it says x equals, we want to find what k is at x equals 2. And we already know that all these are continuous, and we've already stated that, but you would have to use the continuous thing. You don't have to state it more than once, but again, just to remind you, we all had that F, G, and H are continuous, and that is because, this thing right there, because of the differentiability. So that's going to be part of our justification. Well, this means that we know that G of 2 is less than or equal to K of 2 is less than or equal to H of 2. Okay, because we're dealing with this value of 2 here. Well, way up here in the given part, they told us this was 4 and this was 4. So the only value that is between or equal to 4 and 4 means that K of 2 has to be 4. So K of 2 is also 4, because 4 is the only number that's equal to 4 on each side. And that is called the squeeze theorem. I can almost guarantee you that that will not be on the test this year. Squeeze theorem will not be on there because this problem was so bad on the AP test last year. So I hope this helps. Bye.